Okay, so in this video I'm going to explain how 99% of the population has been fooled into thinking that there is no gravity in space at the International Space Station. Just gravity disappears apparently, and you just float around, And you're probably saying, oh, God, Rawls, right? You're just stupid. I've seen videos like, I'll show you a video here. They're obviously floating around. You can see them here. There we go. Look, floating. Look, you're wrong, Walrus Rider. You're wrong. He's floating. No. He's falling. You go, hang on a minute. He's not falling. He's floating. You can see him. He's floating around. Okay, I'm going to explain how it works. Why it looks like he's floating, but he's actually falling. He's actually in free fall at the moment. He's weightless because he's not feeling any force, but he's in free fall. So let's get on to this. So I'll start off by looking at the actual space, the launch of Crew Dragon, and you'll be able to see here what actually goes on. And I've got my sheet of paper here. I'll show you the trajectory and what's actually going on and how the astronauts become weightless in space. So here we go. So you see here they're zipping along. They're experiencing some G-force here. You see it's accelerating there, 400, 500 kilometers an hour, 2 kilometers altitude. So this goes on for a few minutes. I'll just zip along. So there we go. At 200 kilometers altitude, they're doing 17,000 kilometers per hour. So that's the altitude they've reached. They sit there for quite a while actually, and they actually just keep accelerating the craft. So if you look at the graph, we'll do the Earth here, and they started off at Cape Canaveral, and they go into the air, and then they sort of go around like this, and then they accelerate until they reach a terminal velocity, which is around 27,000 kilometers per hour. And you sort of think, well, that's very fast, isn't it? 27,000 kilometers per hour. Why are they going that fast? And I'll explain to you why. Because gravity still exists. Let's see if we can. I just want to see. There we go. You can see right there. They stop almost precisely at 27,000 kilometers an hour. They're at 200 kilometers altitude. And if you go into, I'll leave a link here. If you go into the calculator tool, you can actually see here at a height of 100, I think it was 199, wasn't it? 199 works out to 7.789 kilometers per second. And if you actually do a kilometers per second to kilometers per hour, and if it's 7.78, wasn't it? 7.78 kilometers per second. Oh, they got meters per second. So we just go 778. So 28,000 kilometers per hour. All right. So what's happening here is, there we go. So we've got this article here as well that explains it as well. Yes, there is gravity in space, and they talk about it, and you can actually work out using Newton's famous gravitational formula there. That since the mass of the Earth doesn't disappear, of course you're going to still have gravitational attraction between spacecraft, astronaut, and the actual Earth. So what's going on here? And they've actually worked it out here at the International Space Station. He's worked it out. It's around 88% of the value of the surface of the Earth. So what's really going on is you're trying to eliminate gravity by moving forward, because the gravitational pull is still happening. So if you look at the vectors, you've got your forward vector going at 7.78 kilometers per second, and in 1 second you're actually dropping down, say 88%. Say let's just put 9.8. We'll just keep it the same as Earth. 9.8 meters in that 1 second. So what actually happens is you follow the curve of the Earth by doing that. So you imagine you go forward 7 kilometers and you drop 9 meters. Forwards 7 kilometers, drop 9 meters, 9.8 meters. Go forward 7 kilometers, drop 9 7.8 meters, etc., etc. So you go toot, 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 toot. And that's why you orbit the Earth. And this will show this to your flat Earth friends. This will totally debunk the flat Earth. So that's how it works. So there we go. So hope you guys understand that. That's why it seems like they're weightless, but they're actually falling. You see there. So if you think about, remember the guy Felix Baumgartner, he went up there and the Red Bull Stratus experiment and jumped out, and he just fell close to 9.8 meters per second and back to the Earth. So if you imagine Felix was here, and he's looking at the International Space Station going by, and if you could see in a telescope, and you'd see like a second later it was 7.8 kilometers away from him, and he'd actually see that it actually dropped. If he had a laser, he'd see it actually dropped 9.8 meters. And if he was falling, if he jumped at exactly the same time as the International Space Station went by, he would actually be able to shine a laser directly horizontal and be falling at the same rate as the International Space Station was dropping as well. So Felix is in freefall. Also, the astronauts in the International Space Station are in freefall as well. They are falling at exactly the same rate as Felix. So I hope this explains things for you guys. If you've got any questions, just leave them in the comments below. And what I'll do is might do another video if you don't completely understand what's going on. So it's basically the forward velocity is counteracting the curvature of the Earth. So you're going in like a parabolic motion. So you're actually falling. This vector is falling at 9.8 meters per second, but you're going at 27,000 kilometers per hour. So you follow the curvature of the Earth. When you add the two vectors, the forward velocity vector and also the gravitational acceleration, you get that curve. And you can actually work it out if you work out the diameter, circumference of the Earth around 40,000 kilometers, and space station goes around the Earth once every 90 minutes, and you can actually work out that they have to be doing around 27,000 kilometers an hour to do one full rotation of 40,000 kilometers in 90 minutes. Of course, you've got to take into account the rotation of the Earth as well, but we won't go into that. So there we go. That's the basics. That's basically why it appears that the astronauts are actually weightless, but they're not actually weightless. And but it is very cool to watch them. And once you understand this, you'll see things in a completely different manner now. They are not actually floating in space. They are actually moving at 27,000 kilometers an hour. You can actually see them going against the Earth. They're moving through space at 27,000 kilometers per hour, and also falling as well in free fall around the Earth. And that is why it appears that they are weightless, but they're actually not.
The view is incredible.
Well, technically they are weightless because they're not feeling any forces. They're in free fall.
We are the experiment.
And you see there. Let's go back. Let's see if there's any cool footage of them cruising through. And you see there, everything's floating in space. So that tin of tuna was going at, if it was tuna at all. It's one of their special meals, I guess. Let's have a look. So you see here, I don't know what they're eating there. Hey, Russian cosmonauts? I'm not too sure. Actually, looks like Russian writing
We are
there.
the experiment.
You see there that it's just that can of whatever they're eating is travelling at around 27,000 kilometers an hour as well. It's pretty freaky, isn't it? It's a bit like when you're actually in an aeroplane and you're actually travelling around 1,000 kilometers an hour, about 800-900 kilometers an hour, and you feel like you're at rest because you're actually travelling at the same speed as the plane. And some cool little experiments they're doing there. But yeah, so there we go, guys. I hope you enjoyed that. You can actually see the curvature of the Earth there. These guys are doing some experiments. You can see there, taking some photos through the portholes there. Yeah, some pretty cool footage here. I might leave a link to this in the description. But there we go. So they are not actually weightless. Well, they're not floating. They're actually moving and falling at the same time. Moving forward at 27,000 kilometers an hour and falling as well. Boom. And of course, the forward velocity depends on the what orbit altitude they're at, and I'll leave the calculator in the description below as well, so you can actually work out different altitudes. Work out at different altitudes how fast you have to go to actually orbit in space. So yeah, you can see clearly there how fast they're going. The Earth is moving very fast below them there. So there we go.
The view is incredible.
Hope you find that fascinating, guys. Want to do some more sort of sciencey things like this in future videos, so I hope you enjoyed that. Give us a thumbs up if you liked it, thumbs down if you thought it was rubbish, and we'll go from there. If people like it, I'll do more videos on it. So okay, cheers guys, see ya.
International partnership